Welcome to Semantic Web Technologies. Lecture 2, Semantic Web Basic Architecture. Part number 4, how to represent facts. Today, we are again talking about the resource description framework, which is used to represent facts in the semantic web. And in particular, we are going to talk about so-called blank nodes, which are nodes that have no unique name and potentially are not referenceable. And we will talk about aggregations of facts that can be aggregated in form of lists. So let's start. First, a question. How should I represent a lecture, for example, that takes place twice in a week and in 2 different rooms? So, on the one hand, I have here a lecture that has a name. And let's take the lecture that takes place at audience room number 3, lecture hall number 3, and it starts on Tuesday on 1:30. And on the other hand, there is a second date for the lecture, for example here, Wednesday, also at 1:30. And then it takes place in another lecture hall. The problem is how to distinguish these facts. So, which lecture hall belongs to which date? If you are going to represent it in this way, then you have no possibility to select which belongs to which. So you have to think of something else. So the problem is, of course, this is not unique and makes a unique selection not possible. The idea is now we can make an ordering or a selection by introducing additional loads into the graph. For example, like that. So here we have 2 new nodes, 2 blank nodes that right now don't have a name. But as you can see here, they have 2 properties. So this blank node represents a place and a time, which has here a room, and on the other hand also a date that combines here in a unique way place and time. So it's called a multi-valued relation that is represented with the help of so-called blank nodes. And here again, you have the lecture. The lecture takes place in a room and in a specific place. So consider there would be a 3rd event with this lecture in the week. Then you could represent it in the same way by introducing a 3rd blank node without a name, because this node doesn't need a name right now. And the node combines 2 or more attributes that then are grouped together for our lecture. So that's pretty simple. In general, these blank nodes are also called B nodes. They can be introduced to represent multiple valued relations, and especially for resources that don't have to have a name. In general, these blank nodes make some statement of existing, of something that has specific properties. So it does not say there is a specific thing that has these properties, but there exists at least one. Just we have not named it up to now. If you look at the RDF code for this simple graph representation, for the RDF node, for the blank node, you have to introduce a new so-called RDF path type. So you define an RDF description which defines your statement here, and you make a statement about this subject, which is the lecture. And within the lecture, you, with the property takes place, add a so-called blank node. And on this blank node, you here group 2 additional attributes that are grouped together. In turtle representation, it's much more easier. Here, for example, what you do here is you say the lecture here takes place at, and now here in turtle this is different. For introducing a blank node, you are using these brackets. So you open a bracket, and then you say this is a blank node that has the following property and the following object. So there's a blank node connected to has date, in a specific date, and also a blank node connected to has room and a specific room, which is represented by some kind of a literal. So these are only strings in this representation. And then, of course, you have to close the bracket again to show that the blank node you have created with these brackets now is closed, and only these two properties, these two facts, belong to the blank node that you have created just now. Sometimes, of course, it might be important to dereference this node. So it must sometimes be able to be addressed from outside. If so, you are able to give this blank node also a name. In that sense, an idea. Here we have called the blank node ID1. And then, if you're talking about blank node with the idea ID1, of course, you can everywhere talk about a node with the idea ID1. And of course, here you introduce a node via RDF node ID as being a blank node that has two properties. If you look at it in Turtle, it's much more easier. So here you introduce the new blank node ID1, and the blank node here that can be dereferenced, so it's a nameable or dereferenceable blank node, is characterized by this underscore in front of the colon, where you have here the namespace or the default namespace for the document. And to identify this node as a blank node, you just have to look at the underscore. So this is a blank node that has a specific name. The name is ID1. And you have here the two properties that are connected to the blank node ID1. It has state and has room. And in the end, of course, you also must model the fact that you have here the lecture that is connected to the blank node. And you say here that the lecture takes place at some place and time that is represented by the blank node with the name ID1. And from now on, anywhere or everywhere in this RDF document, you are able to address this node, as long as the node has a name. So this is the possibility to introduce nodes that do not have to have a dereferenceable URI from outside, and that do not have to have an existence of their own, that might only exist in this RDF document, and therefore they don't have a unique name or only have a name that can be referenced within this document. So this is one nice thing to have in RDF, and it can be used to make existential assertions. Okay, so let's come to the second part of this short lecture. We want to talk about lists, and lists are nothing else than some kind of general data structure that helps me to aggregate a number of facts or a number of resources or literals in RDF. So it's kind of a shortcut. It means it has no additional semantic expressivity, but it saves time, it saves space and effort to write everything down. And you have two different aggregators here in RDF. The one thing is called the container, which is a kind of open list. It means if you define a container, you can extend this container afterwards. And on the other hand, if you want to have a closed collection of things, a closed list, then you define a so-called collection. This is a closed list, and no further extension is possible later on. So let's start with a container, with the open list. The underlying graph looks like this, and as you can see here, we have a statement about something. It's here our lecture, and we say the lecture has participants, and all these participants there are together in a list. So it's kind of a shortcut. So we have one property, participants, which is connected to a list or a container of objects that are here dereferenced by their URI, and the property connecting this blank node with the single items of the list is here RDF _1, _2, _3, and so on and so on. So you have there a unique property for each single item in the list. And of course, you have to say or to state that this blank node really is some kind of a list, and therefore you need this type statement and say this blank node is of type RDF sequential, which means it's a sequential list, an ordered list where the order of the items with 1, 2, 3, 4, and so on is somehow important. Okay, so let's take a look, one step back, let's take a look how we do formulate this in Turtle, for example. So in Turtle, it's pretty simple. In Turtle, you start here by defining some prefixes that are required to define these URIs. And after that, you have first the statement that this lecture has some participants. So this is one here. The lecture has participants. Then you have the blank note. See here, the bracket, which is the red blank note. And the red blank note is of type sequential. So it's this here. A means RDF type of, RDF sequential. And then simply you have all the other properties connected to that blank note, which come here, RDF 1, 2, 3, and 4, that are connected to the items of the list that are represented by their URI. And after that, you close the brackets, and then you have finished to define this container. So this is a list that can afterwards be extended, for example. Okay, but we have forgot one thing to mention, that there are different kind of containers. So up to now, we have learned about the sequential container, which means there we have an ordered set of elements. So the order is of some importance. On the other hand, if you simply have a collection and it should represent an unordered set, so if the order has no importance at all, then you define a so-called RDF back. Then this should be simply of RDF type, RDF back, and then the order has no relevance. And on the other hand, you have a third possibility to define a collection where you have to choose among all of these elements just one. Then you define kind of RDF alternative. So then it's here, RDF alternative, and then this defines an alternative of elements where one of the alternatives has to be chosen. So, pretty simple. Let's go one step further. Now we want to define a list that is closed by definition. So if you see this here, this reminds you somehow this structure on so-called linear lists that you know from basic computer science. And this kind of representation of some knowledge reflects closely the connection that has RDF to languages from artificial intelligence like Lisp, for example, where you have structures like this. So here you have a simple linear list where you say, again, here we have the URI of the lecture, and we say the lecture has participants, and then you have a predefined number of blank nodes that each represent the head of a list. And it means here is the header element, the first element of the list, with the property RDF first, and then here you have the URI representing this list item. And then you say, okay, and after that comes the rest of the list. And the rest of the list is structured in the same way. So you again have a blank node that points to the head of the rest of the list, the first element. And the rest of the list, again here, it's two nodes. And you go on and go on and go on. And in the end, you say, okay, here does my list stop. And then I define the rest of the list to be null. And this can be expressed by RDF nil. So here ends the list. We take a short look at the according RDF encoding. How do we encode such a list in RDF? It's pretty simple. We just take a look at the turtle because the XML we don't need. In turtle, again, we have some definitions for the prefixes we require, for example, for RDF. Then our default prefix and base prefix that is defined here. And then I say my lecture, semantic web technology, has participants. And then, of course, as you see here, you have 4 blank nodes. You have to define 4 times blank nodes. So we have 4 brackets opening. Let's take a look at the first bracket. So the first bracket, there we have at first here the property RDF first. It's that here. And then we have the first element. And after that, the second property of that blank node points to the rest of the list. So we have here RDF rest. And then the second blank node opens. And here again, you have these brackets and so on and so on. And in the end, you see here the rest of the list in the end from the last node points to nil. And after that, you have to take care to close all the brackets again. And don't forget the period that represents the end of the statement. So that's pretty much to write, you will think. You're sure. Therefore, in RDF, there are some shortcuts. And as you look at this is much more easier, but will be interpreted in the same way. So here you have other kind of brackets. So you have braces here. And you see here the statement that our lecture, Semantic Web Technology, has participants. And then comes the list here in braces. And then you simply list all the URIs of the elements that are contained in the list. And an RDF interpreter does nothing else than to substitute this list by this structure. So it's just a syntactic extension, nothing else, and it saves you a lot of time when writing this. Okay, so what have we done today? We have defined first so-called blank notes, which are to reference or not to reference things that don't have an existence in the real world or outside our RDF document, but nevertheless can be referenced if I give them a name. And on the other hand, we have talked about aggregations of facts or of items in the sense of open or closed lists. Next time, we will talk about another feature of RDF, which is called reification. And then we are talking about meta modeling. It means we will model facts about facts. So see you next time.